All right, we're back. We're still on page 84, and now we're going to do a u substitution problem that really gets into what u substitution is all about. So I'm going to do a let statement. I'm going to say let u equal 3 pi over 2 times x minus pi over 5. Now, what's weird, well, it's not weird, but in this problem, the initial bounds that I'm given are x bounds. But I'm going to change the problem into a problem involving u. So I need to change these to become u bounds. So if x equals 0, then u is going to be 3 pi over 2 times 0, which you obviously don't need to write, minus pi over 5, so negative pi over 5. And if x equals 3, then u is going to be 3 pi over 2 times 3 minus pi over 5, which is 9 pi over 2. I need to write it. 9 pi over 2 minus pi over 5. So 45 minus 2 is 43 pi over 10. Okay, so what is happening? All right, so we're going to try to solve. So we have like a new problem, right? We're going to try to solve the sine of autocorrect. What are you doing? All right, the sine of u equals negative radical 3 over 2, where u is in between negative pi over 5, and then for some reason we don't include that, 43 pi over 10. All right, but we're not done with that. We'll return to that in a second because we really want a common denominator. So like we could use 10 right now, but let's see what our solutions look like and deal with it then. So here, what could u be equal to? Well, I know just by thinking about it that u is either 4 pi over 3, or u could be 5 pi over 3, right? Those are the angles that I'm looking for. So what I really want is a common denominator between 5, 10, and 3, which I'm thinking, so 5 and 10 share 5, and then there's another 2, and then there's a 3. So 2 times 3 times 5 is 6 times 5 is 30. So I think we should use 30. So really, I need negative 6 pi over 30 less than or equal to u is less than 3. So 129 pi over 30. And I'm going to change these to be u equals 40 pi over 30, or u equals 50 pi over 30. All right, so I think we're ready. The only thing that I need to do is I need to rewrite 2 pi, right? 2 pi is really 60 pi over 30. So I do have to watch out though, because it's possible that, so if you have all your solutions like lined up, I'm gonna write something then erase it. So if you have like all of your solutions lined up, right? It's possible that, you know, maybe this is 40 pi over 30. This is 50 pi over 30. But when we subtract, we could still stay in the bounds. Like we might not, but we might. So here, if I subtract, I go this way, I'm gonna end up at negative 10 pi over 30, which is not, it's out of the bounds already. So since that's out of the bounds, I know I don't have to do it, but it's possible that you need to actually go backwards when you're solving these problems. Like you don't always just keep adding the period. Sometimes you have to subtract the period. In this case, since this value that we've already found is out of the range, we know that we don't have to go backwards. So I'm going to erase all of this because I don't really want it clouding up my work, but that's a thing to think about. So here we go. So u is 40 pi over 30. That's the first. And then the next is 50 pi over 30. And we just keep adding 2 pi. So we're adding 2 pi like every other time. So I'm adding it to 40 this time. So it'll take me to 100 pi over 30. Then I'm going to add it again, and that takes me to 110 pi over 30. Now, if I try to add it again, I'm going to be out of the range because I will have gone too far. So I'm stopping there. because I need to stay between negative 6 pi over 30 and 129 pi over 30. So I stopped there. But this is not the original question, right? The original question said that this was our argument, and we let that be u. So now what I'm going to do, I'm going to go backwards. So I'm going to convert my u back into x's. And the way that I do that is I need to rewrite this thing. So I don't need to do this, but I'm going to rewrite this as something over 30 to begin with, because it's just going to make life easier. So 3 pi over 2 x. And then what is that? Minus pi over 5, so minus 6 pi over 30 equals all of these things. 40 pi over 30, 50 pi over 30. So you'll see I'm going to do something weird. So you can just solve each of them individually. Like, there's no shame in that. And you'll get it, and it'll be fine. I prefer to solve all of them at once. So, and I'm not going to skip as many steps as I like to. I like to go straight from this step to the final answer, because I think you can do it. It's like not really that bad. So what you need to do, basically, right? Very basically, you need to add 6 to every numerator. So that's 46, 56, 106, 116. So we add 6 to every numerator. Then we're going to double every numerator, but instead of doubling them, I'm just going to cut these in half. So 15, 15, 15, 15. Then I divide by 3 pi. It knocks out all the pi's. And then dividing by 3 takes all the 15s that are here and makes them 45s. So for example, we can do it. Ready? So we add 6 to the numerator, and then the denominator became 45. Add 6 to the numerator, and the denominator became 45. Add 6, and the denominator became 45. Add 6, and the denominator became 45. So that, you can do that. Like, I believe in you. You can do it. If you don't like doing it, here, I'll do it over here. So I mean, I'm done. Those are my answers. But let me duplicate this and show you if you want to do the work. Here you go. So your first step, you're going to get 3 pi over 2x equals 46 pi over 30, 56 pi over 30, 106 pi over 30, and 116 pi over 30. So I feel like just a long time ago, someone convinced a lot of my students that they can't do anything in their heads. And that is just like not true. I'm multiplying by 2, but I'm also canceling. So we'll get this 56 pi over this, 106 pi over this, 16. So this is all like, this is what we did in our heads, and it was not bad. You just got to really focus, and I know that's not always easy. So the pi's get knocked out, and then you divide by 3, so you get x equals 46 over 45, 56 over 45. It'd be weird if I managed to somehow get this wrong multiple times using multiple approaches. That's always like my fear. It's like, I so don't understand something that I've come up with a completely consistent alternative approach. And it like consistently gives the wrong answers, but consistently enough that I never really notice. That's my fear. That's like a weird nightmare. All right, let's try to solve this. So solve sine of 3 pi over 2x minus pi over 5 equals negative square root of 3 over 2. We want to solve for x, get out of the parentheses, and then we're going to do such that, which is control equals 1 to the left, and then 0 less than or equal to, it's control equals, and then like just find it in there, less than or equal to that, less than 3, and enter, and we get all of the answers that we found. So this is what u-substitution is all about. So when you are solving a problem using u-substitution, you completely change the problem into this whole new coordinate system where u is your independent variable. And when you change to an independent variable of u, you have to change your x bounds. Like, the x's are no longer really relevant, but the substitution gives you the way to convert them. Take all your x's and convert them to u's using this. So that's what we did. And then if you get yourself some common denominators and really think your way through it, you make the problem so much easier on yourself. And I recommend that you always try to do that. So our final answers here, which we got 2 different ways. I think you should try to do the first way because I believe in you, but you are free to do it whichever way you want, is this. These are our 4 answers. We checked them, we got them right. So I will see you in the next video where I bet we're just gonna do more of this. So see you there.